Okay, so hello everyone. So thank you for watching my lecture video. So I'm Dr. Wang. So this video is for the sample problems uh, for number 11 to number 20. Okay. So this problem number 11 says we have okay. So mm, for those automobile owners is twice like okay. So they will buy two insurance coverage. There's a collision coverage and disability coverage. Okay, so uh, so this is the number of by this uh, by this is twice as by this. Okay, and so this is the event that I purchase those coverage is independent of this. Or those two by this, by that, independent. Okay, so then this is the probability that by both is this. So we have this P. So both we can put this as let's say C and D. Okay, so C stands for the collision coverage. So this probability is this. Is the probability that the car owner purchase both is this. And because by C and D are independent, so we know this probability equal PC times PD. Okay. So the relationship for like by PC and PD by this and by this is twice. So is twice as like by. So this means PC equal 2 times PD, right? Okay. So now we can find the probability. So what is the probability? So probability we want to find is this. We want to find this probability. Actually, is PC, not C and not D. We are not by. Okay, we want to find this probability. So this probability we say equal 1 minus P by C or D. So by C or D is equal P. This is a PC plus PD and minus, let's say, so we use this formula, right? A or B equal PA plus PB minus PAB. So here become plus PC and D. Okay. So we just need to find PC or PD. So let's find PD. Okay. So let's say PD is X. Suppose that's X. Then from here, from the first relationship, we can find this PD or X. So we know PD is X, PC is like 2X times X equal PC 2X times X equals this. So X squared equal Mm. Says link this saying we can find x. Okay. So then this probability equal 1 minus 2x minus x minus plus. So here we need to find x. So we need to calculate. Okay. Okay, so for this problem 12, a doctor is studying the relationship between blood pressure and heartbeat abnormalities. Okay, so wanted to study their relationship. So and now the blood pressure. So for blood pressure, we have 3 types: like high, low, normal. And their heartbeat have 2 types: regular, not regular. So here we have 2 factors: blood pressure, says we have 3 levels, we say, and this heartbeat. So we can use a table for blood pressure. Like blood pressure, we have like high, low, and normal. Okay, like here for blood pressure, and then for heartbeat, here is the blood pressure. So heartbeat we have regular or not regular, right? Okay. So we have 2 factors, then we can use this table. So totally 100. So we just fill out the table. Okay. So let's say 14%, 14 have a high blood pressure. So this is 14, and 22 low. So this also total in this direction. Okay, so then we know the percentage for normal. So here let's say the 36 high or low is 36. So 36, 36. So 64, 36. Right? Okay. So for blood pressure, we split 100 people into 3 parts. Then for regular, for heartbeat, regular, not regular, regular, we just say not regular. So this is 15. Okay, so then this is 85. Okay. So to fill out these tables, we need more information. So let's say of those people, of those with irregular beat. So those people, we have a 15 line, right? For those 15 people, 1/3 have high blood pressure. So 1/3 of 15 is 5, right? 1/3 have high blood pressure, yeah. Okay, so now for those people, for those normal people, for those 64 people, so here we have for 64 people, one eighth have irregular heartbeat. So 1/8 for 64 is 8. So among them, 8 have that. Okay, so we can fill out this table. Let's say so here we have 2 here, right? Yeah, and then here 22, so here's 20. Okay, and here's 14, 5, so here's 9. And so we can find this number. What is the number here? 864 minus 8, 56. Okay, so we fill out this table. So now we can find, we can answer the question. So what portion of patients have regular heart and low blood pressure? Low blood pressure, regular heart, so regular is 20. So answer is 20. Right? So says regular and low 20, right? Okay, so for problem 13 says, and actually is studying those things, studying 3 health risk factor ABC. So we have 3 risk factor ABC. Okay. For each of these 3 factors, the probability is 0.1 that the woman in the population has only this risk factor. Okay, so this 0.1, like 10%, it has only this, like only A, no B, no C, like that, right? So okay, so here we have 3 facts. So maybe we can use this Venn diagram. So A, B, like here, A, B, C, okay, and this is the other side. We can use this graph, okay. So let's say, so only this risk. So only this risk is here's this 0.1, here 0.1, here 0.1. 0.1 means like this part only. So here's only A, right? This part only A. So only B, only C. Okay. So for any 2 of these facts, the probability is thus that he has exactly these 2 risk factors. So exact 2. So exact 2's this part, like here exact 2. So here exact 2, right? Those part. So here exact we have exact 3. So this is 0.12. So 0.12. So 0.12. 0.12. Okay. So this 0.12 is exactly this 2. Okay. Okay. So the probability that a woman has all the 3 risks, giving that, so there's a conditional, giving that he has A and B is thus. So he has A and B is which part? So let's see. So A and B is this part. Okay. So here's A and B. So among the A and B, he has, this woman has all these 3 factors. So this part is one of 3 of all. So here, let's say, so we put it, okay, like this. So here's 12. So here, suppose with X, but this X count for totally count is 1 of 3 of total, right? The probability that a woman has all 3 risks, given that he has A and B is this. Okay, so we can find this. So let's say, so this part X is 1 over 3 of O. Let me see. Okay, so let's check this. So we have this X means O. So over this condition, this part. So we just check this part. Okay, so this is 1 over 3. Okay. Okay, so this sentence we need to understand. Like the probability that he has all the 3. So this is the X, but giving that he has A and B. So giving that means we just check this part condition. This part. So from here, so we can find X. So let's say we can find X. 3x equals that's 2x. 3x equals this. 2x equals this. So we can find this x equals 0, 0, 6. Okay. Okay. So we say this is 0, 0. This part is 0, 0, 6. Okay. So we know all the information. Yeah. So now we can find this probability. If we want to find the probability that a woman has none of those 3 factors. So outside, none of those risk factors. But given that he does not have risk factor A, so this conditional probability just like that, we want to find this probability. He has none of this, like A, no A, no B, no C. Given that he does not have risk A, we need to find this probability. Okay. Okay. So let's say, so the notation quite. So total is just not A. So let's say what is A? So we can find A is, we can find this is 0.1 plus 0.12 and 0.06. So we can check this A, right? So this A, we have 4 parts. So we find this A equal, so let's do some calculation. Okay, we find this equal 0.4. Okay, so A bar is 0.6. So A bar is not A, not A. So not A is outside of A. So outside of A is not, so not A, not B, not C. So not A, not B, not C. So what is not A, not B, not C? So we just find A and so let's check outside. So outside is this. Okay, that's outside. So here's let's find this. So here is, let's say 0.1, 0.1, so 0.3 plus point. So here's a 0.1, 0.1, so 0.3, so plus, so 0.12, 0.12 is 0.36, then plus 0.006, right? So this is A or B or C. So we find this equal 0.3 and 72, right? So this is 72. Okay, so this means other side is 28. Yeah, 28. Okay, so there's a condition, there's a probability. So a bar not A is this. So among not A, so other side is this. 2A. Okay. Okay. So for this problem, okay. So this the number of column, this A can be 0, can be 1, like a number of column can be no column, or 1 column, or 2 column, and until infinity. So this is the probability for have n is, we have this. Let's say, so the probability Pn is probability that n equal n. So we have the relationship n plus 1 equal 1 over 5 Pn. So we know all probability, so n equals 0 to infinity, so this equal 1. Okay, so we can say, so we use P0 as we just use P0 and write all other probabilities in terms of P0. So P1 equal 1 over 5 P0. And this, so P2 is 1 over 5 P1, and then 1 over 5 square P0. Right? Okay, so we can find P0. So we say, so we have this P0, then 1 plus 1 half. So 1 plus 1 over 5 plus 1 over 5 square. So this is 1. So we can find P0, right? Because this summation is P0, so this is 1 minus 1 over 5. So this equal P0 and 5 over 4. Okay, so P0 equal 4 over 5. So now we can find everything. Okay, so what we want to find the probability that find more than 1. So we just need to find this probability. Yeah, and we want to find is a more than 1. More than 1 is at least 2, right? So this equal 1 minus b, n equal 0, and n equal 1. Okay, so P0 equals as a P1, so that's equal just 1 minus 4 over 5. And what is P1? 4 over 5 times 1 over 5, 4 over 25, right? So this is answer. Okay. Okay, so for this problem, they have 3 kinds of coverage, A, B, or C. Okay, so we have this like 3 factors. So we can use this Venn diagram, like A, B, okay, A, B, C, or it is none of them. Okay, we can use this. Okay, so this is the employees may choose exact two of them, or they may choose none of them. Okay. Okay. So choose two of them. Either choose this A and B, or B and C, or A and C. Choose exactly two of them. Okay. Okay. So now, but what we don't know is how much to choose here. So choose A and B. So we put suppose we put X here. Choose A and B. Choose B and C, Y, and choose A and C, Z. So here's 0, here's 0, here's 0. So those are no one choose exact one. So here's just exact 1, and here choose exact 3, also 0. Okay. So we just need to find X, Y, Z. Okay. So outside, let's see. The individual may choose exact two of them, or they may choose none of them. The proportion that choose covered A, B, and C are such. So choose A. So choose A. Let's say, so from here we can find choose A. So choose A means X plus Z. So X plus Z is 1/4, right? So just choose A. So choose B. Choose B is X plus Y. So choose B is 1/3, and choose C. Choose C is Z plus Y is 5/12. Okay. So here we have 3 unknown variables. So we have these 3 equations. So we want to solve them. Okay. So the question is, what is the question? Questions determine the probability that they will choose no coverage. So what we want to find is outside, or choose no. So outside is 1 minus X minus Y minus Z, right? So this is what we want to find. Okay. So we just need to find X plus Y plus Z. So we know these 3 equations. We just add them these 3 equations. We can find 2x plus 2y plus 2z, 2y plus 2z equal. So we use common denominator equal this, add them up. So this equal 1/4 becomes 3/12, right? So plus 4/12 plus 5. Okay. So this is let's see. Add them up or equal 1. Okay. Right? So X plus Y plus Z equal half. So this equal half. Answer is that. Okay. So here, this N is number of claims. So this N can be number of claim, usually can be 0, no claim, 1 claim, 2, until infinity. So we know there's a probability like N equal N, so equal this 2N plus 1. Okay. So this is for 1 week. So here, what we want to find is determine the probability that exact 7 n equals 7. But this 7 is in 2-week period. So we can say week 1, week 1, week 2. So total is 7. So week 1, so we can list week 1 like equals 0, then week 2 is 7. So week total equals 7, right? We just talking about week 1 plus week 2, the claim is 7. Or then 1 or 6 or 2 or 5 like this, right? So there the claim in week 1 and in week 2 is independent. So we can find, let's say, like for V1 equals 0, V2 equals 7, such a probability is 1 over 2, 1, right? 0, and so when x equals 7, n equals 7, happening 7 times, this is 8. So this is 1 over 9. So we find this is 1 over 9, so 1, 6, also 1 over 9. So let's say, like n equal 1, so this is 1 over 2. And n equal 6, 1 over 7. So we get another 1 over 9. So the answer is 1 over 9. So how many those cases? So from 0, 7, 1, 6, 2, then until 7, 0. Right? So we have 8 cases. So the answer is this. Okay. Okay. So for problem 17, so there will pay hospital claim. So number of claims, the number of claims that include this room or also include emergency room or operating room charge is 85% of total number of claims. So some claim include emergency room or operating room. Okay, so some claim do not include emergency room. Okay, so let's say. Okay. So it also say that emergency room is independent of operating room charge. So here we have two things like okay. So we have two things like emergency room, operating room. So we can say we can regard this like we use E for emergency room, and this thing happen or operating room. So this or this, such a probability is 85%. Right? 85% of the total. Okay. Then let's say the number of claims that do not include emergency room. So it means like E bar. Those probability equal 25. Okay. Okay, and also we know this E and O are independent. So what we want to find? We want to find the probability that the claim. We want to find the probability that the claim include sus. So we just find what we want to find this probability for we want to find PO, right? Okay. So if PE bar equals the same, we know PE equal 75, right? Okay. So we just plug in here. Okay, so we just plug in here. So PE or O equal PE plus PO minus PE and O, right? But the P and O is just PE times PO, right? Because they're independent. So this equal 85. So we know PE, yeah, so we can find the PO, right? PE equals us, so we let the PO equal X. So we can have a form like this, so we get an equation about this X, right? So we can solve this this equation easy. Okay. So for problem 18, say we have two instruments. We use them to measure the height of a tower. So there will produce some arrows. So arrow made by this instrument is normally distributed with mean zero and standard deviation z. Okay, so we can regard this as x. So x is the arrow made by this. So this x follow normal distribution, mean zero, and standard deviation is thus. Okay. So the other one, made this one. So arrow. So we have two arrows, right? So this arrow, we denote this the y. This one follow normal distribution means zero, but standard deviation becomes thus, like 0.00044 h. Okay. And so okay, so here independent. So x and y are independent. So what is the probability? We want to find out what is the probability that the average value. What is the probability? So the average value is x plus y divided by 2, right? So this is the average. The average is with 0.005 h. Okay, so we want to find the what is the probability that the average value is with. So this means with this with meanings. So this number within one, like we say like a this number a with 1 of the height. So within one means like the so is so this means this actually is between like this between the and negative like in this range. Okay, so this number is within this. Okay, so we want to find this probability. Okay, okay. Okay, so we want, so for this problem, we want to know the distribution for x plus y divided by 2, right? Or just x plus y. Let's see. So x plus y distribution. We say the normal plus normal equal normal. Mean is this plus this. For the standard deviation, you cannot add them up. So, but the variance, so the rule is mean can add it, and the variance can add it. So standard deviation actually is this variance. We say just take variance. So this, let's see. Suppose we say the sigma 1, sigma 2. Okay. So this equal variance sigma 1 square plus sigma 2 square. Then take square root. Okay. So we just use this. And so divided by 2 is, so divided by 2 just divided by 2. So variance, so here just divided by 2 still 0. So here just divided by 2, half. Okay. So for this problem, so we need a little bit of calculation. So x plus y over 2. So we can regard this as let's say this variable a, right? So this a follows this normal, means 0, and standard deviation. So you need to find this square plus this square, take square root. So here with the calculation, so this equal this number, so we can put h, right? So we have this number. So this number is 0.00056 square plus 0.044 square, then take square root. Okay, then you can find so then there's probability. I think there's a probability just there's probability. So there's a between this. Between this. So just 2. So we just find this cut point. Then so check the normal table. Okay. So this a cut point. So we just changing this to standard normal. So this, let's see, like so minus mu divided by sigma, right? So h cancelled. So you can find this probability. Okay. So this is normal distribution problem. Yeah. Okay. So I have no enough space. So but you can do this now, I think. Okay. So problem 19, this one is easy. Like we split all people into these 4 parts based on their age. Okay. So for those people, the probability for accident is this, so much chance for this accident happen, and so portion of companies insured driver. So among those people, how, let's say, so we just talking about how here is how so much percentage of people are those people, like from 16 to 20, right? Okay. Okay. So now let's say, so what is this probability has an accident? So such a probability is, okay, so equal like those people, then multiply their chance for accident, right? So then for those people, and the probability for them will have a car accident. Then those people, 49% for those people between ages 31 to 65. So for them, 002, right? And for those 28% older people, so they are 004. So we say, so this is the probability for have a car accident. So this is for all people, right? So we have actually 4 parts. So those parts is young. So the part is young people, okay. And this is just a middle age from 21 to 30. So we want to find the probability that the driver age is this. So we just find this part. What is the probability? What is the chance for this part? So we just need to find the probabilities among the total. So this is total car accident. Then what is the proportion for the car accident just from those young people? Okay. So in some textbook, we just use this as we say, like a Bernoulli formula. We want to find this, like, oh, something happened, already happened. Then we find what is the chance this is from this part. Okay. Okay. So for problem 20, this is the insurance company insured life insurance policy in 3 categories. We have 3, standard and preferred and thus. We have 3 parts. So of the company's policy holder, 40% are standard and 50 are standard, 40 are thus, and 10 are thus. Okay, so this is a no overlap, right? No overlap. So 50 those, 40 this, and 10 this, so then like total is 100. Okay, so for those people, like we just split these people into 3 parts. Okay, so for this part, the probability for die is thus, and for this part, the probability for die is thus. Okay, just like that. We split people into 3 parts. Like for this part, is thus. We just split this into 3 parts, and for those people, so we count for we can put okay, we can regard we have 50 people is S, and 40 people is P, and 10 people, so totally is 100. We just we split 100. We split 100 people into 3 parts. Okay. So now let's see. So for die, let's see. So for those die is only thus. So 1%. So 1% is the meaning that here we have 0.5 people will died, right? And for those probably 0.005. So we just multiply, let's say So 40 multiply 0, 0, 0, 5 equal what? 2.2. Yeah, 0.2 people will die. And for those 0, 0, 1. So 10, so this 10 multiplied this just 0, 0, 1. Okay. So we can say among 100 people, totally so many people will die, right? Okay, so the question is, okay, so we from the died people, so what is the probability that this died one was from this part? Okay, so we can say the died one, we can put the died one is 0.5 plus 0.2 plus 0.001. So then, so those just come, so 001 over all. So the probability is this. Okay, so let's multiply 100. Okay, so this is 1, this is 50, right? This is 20 and 1. So this is just equal 1 over 71. Okay, just like that. Okay. Okay, so this is let's say problem from 11 to 20. Okay, so we can stop here and okay, bye bye. So see you next.